Hello everyone. So in last class before spring break we finished section 7.1. So today we are going to start 7.2. So we don't have any complicated thing here. So we discuss how we are interpreting the curve under a normal curve, and we are finding the variable values from a normal distribution or from a normal variable, from normal random variable. So how we are going to do this? So let's see what we have in next slide. So you can see standardizing a normal random variable. So it's nothing different than we did already before. So in chapter 3 or 4 maybe we standardized variable, we find out the z value. So this formula is exactly same as z value. So in this formula, you can see we have here you can see this formula is exactly same we discussed before. So this x is a general x, and we have population mean is mu and population standard deviation is sigma. We already know about this. Now, when we are converting the values, x values into z, this z is following now normal distribution with mean 0, mean mu 0, and standard deviation with mu equal to sigma equal to 1. So that means this z is following standard normal distribution. And we are saying that standard normal distribution will always have mean 0 and standard deviation 1. Fine. So we are familiar with that formula. So we will use this formula a little bit later. So we are also familiar with the standard normal curve, because when we are discussing about standard normal curve, then we have mean is mu and standard deviation is. Okay. So let's see how we what is the difference between standard normal curve and normal curve. So if we are discussing about normal curve, in normal curve we have mu, and again we have pardon me. So in normal curve we have mean, we have sigma, negative mu negative sigma, then we have mu, and we have mu positive sigma. And in standard normal curve we already know the value of mean and these 2 points. So mean is 0, this point is -1, and this point is +1. So what we know here, so we know that the value these 3 point is this -1, 0, and +1. And for here we know the difference between normal distribution and standard normal distribution. For standard normal distribution, in this line we are saying that this line we have z instead of x, but when we are discussing about normal distribution, in that line we are representing x. So you see this is the difference between normal distribution and standard normal distribution. Okay, so let's move on now. So in next slide we have different values for IQ score, and all the different values we have mean, which is um, mean is 100 and the standard deviation is 15. Now we are saying that an individual IQ score is 120 is 1.33 standard deviation above the mean. So why we are saying that? Because we are finding the z score. So we are finding the z score using x, which is 120 value, and we know already 100 is the mean, sigma mean value, and we have sigma, which is 15. That's why we are getting 133. So what happened if we are discussing that value what will be the value if a random people have IQ score which is not 120? If a random people have IQ score which is not 120, then what would be the difference? So we suppose the random people have IQ score which is 80. Then we will find the Z score on the same way. So we are writing the X, negative mu, and sigma. So we are writing the X value which is 80 now. Negative mu is 100, is the same. And we are saying the standard deviation is 15. Now we can see this value is now negative 1.33. So now we will say that the person who have IQ score 80 is 1.33 standard deviation above below the mean. So in that case, when we have positive value, we are saying it's above the mean. Now we have negative value, so that's why we will say below the mean. This is the only difference. So when we have negative value, then we are saying this is below the mean. When we have positive value, then we are saying it's above the mean. So now this is the main difference between negative and positive value of Z score or standardized Z value, standardized normal variable. Now let's move on. So now we are finding the area under this point. So if you are going, we are saying that Z value from here is negative 1.33. Now we are finding this Z value in the standard normal distribution. So now I will say that how we are going to use this Z value. So now we have a standard normal table in your Blackboard under chapter 7. You can easily go there and find this table. So what we are doing, we are finding 1.3 from the first column. You can see Z here. So from here we are finding 1.3, and that second digit, these three digits we are finding from this line. So you can see this. Now they are intersecting 9.1. They are intersecting 0.9082. It does means that so it does means that for a Z value, so for a Z value, suppose we have a normal standard normal distribution like that, and we have Z value, this is 0, and we have Z value which is Z, and the value is suppose 1.3. So for that, oh, okay, this is on that side. So so if we have Z on that, which is 1.dz is that value, then we are saying the area on that side is this point, which we are finding here. The area is that point. You can see. So when we have Z value, now we are finding the area like that way, area or proportion like that way. Okay, so now we can move on. So we have okay, so for Z 1.33, we have area which is 0.9083. So whenever we are using Z, we are finding the area from the left, from that point. So that means so whenever we are finding the area is from the left. It's starting from the left. From the left up to this point. So from left up to the point we are finding the Z. This is our Z point. So that's from the left, all the area we have here. This is our, so this is our area on the left from this Z score. Now we also have area on the right, so we know the total area in under the curve is 1. So the total area is 1. This total area would be 1. So that's why if the area from that point on that side is that 1, then if we subtract this area from 1, then we will get the area on that side only. So that's what we are doing to find out the area on that side here. Okay. So we can move on now. These slides, we already discussed this when we did our empirical rule. So this is nothing new, but we are seeing the same thing in a different way. So now again, okay. So what we need to know when we are calculating or when we are considering this kind of situation. So we need to know, we will be asked to find out two different kind of questions. So one question is find the area on the left from a specific point. For this first case, we have x. Find the area on the right for a specific case. For this case, we have x, and find the area between two different values. So we need to find out those area or proportion, whatever we are saying this. Now, here what we need to know to find out a normal random variable value. So what we need to know, we are considering here, we have to draw a normal curve and shade the area we want to find out. So that's one is our this one is our main important task to do. So what is that? So for the first one, it's saying that draw a curve and shade the area you want to find out on which side, on which area we want to find out. So we have to do that for the first one. Now the second one is saying that use table V to find out the z-score that corresponding to the shaded area. So this is saying that we have to use the table V to find out the shaded area. So where is the table V? Let's see how we can find out the table V. Okay, so let me share my screen to you. So here you can see my screen now, I believe. So now you can see if we go to the browser and we see here we have under course when you are going to do your Blackboard under course material find chapter 7. So where chapter 7 you have normal table, which is BTB. This is our standard normal probability table from the left. So this table we will use to find out the area. Right? So let's go to the PowerPoint now. Now you can see we have, so we know second point how we are using that, and third point is obtaining the normal value from the formula x. This one, so this formula is the important formula we need to know. Okay, so we will focus on that. Now here we are using a specific situation. So it says that the combined GRE score is normally distributed with mean mu and standard deviation 189. So this point you are seeing here, this is our mean mu. So the point is, seeing this point is our mean, which is that. And this point is our standard deviation, which is sigma. Now, what is the score of a student whose percentile rank is at the 85th percentile? Now it says that what would be the x value for a student whose percentile is 85th percentile. We know to find out x, we have a formula which is so the formula was v sigma positive mu. That was our formula. So now we know mu, we know sigma. We need to find out z value. So for there you can see okay. So the area we have here is this is the area we have here. So so this one is our area. So which is area is 85th percentile or 0. 0.85. This is our area. Now we will use our z table to find out the z value. So now what we need to find? We need to find out the z value. So we have the area which is 0.85, right? So let's go to the z table now. So now we have the z table in our. So we have the z table in Blackboard. So we cannot access Blackboard like that. So what we need to do, cancel this, then we can access Blackboard. So go to the Blackboard. So we can remember our area was 0.85. So we are finding the area here. Where is 0.85? You can see we have 0.93. So we are going up to find out 0.85. So we have 0.88, 0.85 could be somewhere. Okay, so we already let's take the value from here, which is 1.4. So it will be easier to find. So let's one. Okay, here is 0.85. This one. Now, how we are taking the value from here? We are taking this value because 0.85 is the closest value from 0.85, and it's from 0.1 is there for the first digit, and we are taking here from the second digit. So which point we are taking now? We are taking 1.04. 1.04. We are taking the first digit after the decimal from this line, and we are taking second digit after the decimal from that line. So which is 1.04. So that's why we are taking 1.04. Now go to the slides again. So slide, you can see here we are using this formula to find out the value. Now we have the z value, which is 1.4, 1.04 for that area. So that was our area. This is our z value for this area. We find out the area. Now we are using the formula and we have this as our x value. So how we are interpreting the person who scored 1.1246 on the GRE would rank in 85th percentile. That was how we are interpreting this. Now we have an example. It is saying it is known that the length of a certain state road is normally distributed with mean 100 centimeter and standard deviation 0.48 centimeter. So what we are doing, we are saying that suppose the manufacturer wants to accept 95 and 90% of all road manufactured. Determine the length of road that makes up the middle 90% of all steel road manufactured. So it does means that we have to, so middle 91. Okay, so let's see what does this means by saying middle 90%. So in, you see in normal curve, the total is 100%, right? The total is 100%. So we will have 5%. I'm not sure why. So in normal curve, we have total 100%. So on that side, somewhere we will have 5%. And on that side, somewhere we will have 5% from beginning, and we will have 5% on the end. That means from this point to this point, we will have total 90% on that 2 point. So we are trying to find these 2 points for this case. So which 2 points? So the top point is trying to find these 2 points where we will have 90%, which is that, where we're 90%. So we are trying to find these 2 points as a z value or as the x value. So we have to find out the z value first and x value. Okay, so let's go and how we are doing. So we are saying that area would be 0.05 and area on that side would be 0.05 because we are taking 5% on that side and 5% on that side. Use that. So we also can use calculator to find out that. For that case, we are not using calculator. So you can see we have area on that side. We have area is 0.05 for x1. That means we will get z1 for that point. So we have to find out the z1 first. So what we are doing for for area 0.05, let's find the area from there. So from normal preview, we get area which is 0.05. So 0.05 will be um, here you can see, okay, it's very close to 0.05 and that one is very close to 0.105. So let's take this point. So now we have negative 1.64 for that point. So you can see negative 1.6 and we have to second digit from here, so which is negative 1.64. That means this one we have z value for that. Okay, let me add a whiteboard here so that we can see the whiteboard. So okay. So in that whiteboard now we have these. So this is our point. So for here we have x1 and we are trying to find out the z1 and the area is 0.05. So we find out the area for that point is negative 1 point. The area for that point is negative 1.64 and we will find on the same way on that side we will find 0.05. 0.05 is from that side. If we are starting from the right, then this area is 0.05. But if we are starting from left, then this point would be the total area on that side would be 0.95. So why we are taking 0.95? Because we from normal distribution table we only can calculate area from the left. So that's why we are taking 0.95 instead of 0.1. Then we will find the x2 value using z2 value here. So let's find the z2 value first using the area which is 0.95. So go to the screen now. You can see we have okay, so go to the navigation. We are finding area for 0.95. So let's go 0.95. So you can see we have to find out the area which is 0.95. And so we have, yeah, it's pretty close to 0.95 and that one is also pretty close to 95. So let's take the first one. So which is, you can see for that one we have this point which is 1.6 and on that side we have 0.04. That means we are taking the point here which would be 1.64. So we are taking this point from here. So now go to the first WhatsApp. Here you can see we have 1.64. Now we are finding x1 using the formula, which is mu plus z1 sigma, and we are finding x2 using mu plus z2 sigma. We know the value for mu, we know the value for z1, which is that one now. We know the value for mu from the question, and we know the value for z now. Now, if we are calculating the value, then we are getting the value we need. So we already have calculation of that, so that's why we are going back to the slide. So you can see after calculating the value, we are getting this, and after calculating the value for x2, we are getting this. So now we also discuss this one. What does that mean when we are using z alpha? So z alpha means the area on the right side, from a specific point. So z alpha, if this point is z alpha, that does means if this point is z alpha, that does means that from that point on the right side, from that point on the right side, we have area alpha area. From that, we have alpha area, you can see. So that's why if we are saying z 0.5, that indicates that from, if this is now z 0.5 area, then this indicates from that point we have area which is 0.5. So z alpha is indicating that. Now, how we are going to find this area? So z.05 indicates we have to find out the area of. Okay, so how we are going to do that? We for from point 15, we have to find out the area. For 1, we are calculating z.15, right? So it indicates that z 0.05. It indicates that the area on that side will be 0.05. And what would be the area on the other side? You know, the total will be 1. So the area on that side would be, so the area on that side would be 1 negative 0.05, which is, so area on that side would be 1 negative 0.05, which is 0.95. Now we have to find out the value for 0.95. So we already find out the value for that. So okay, so if we are going here to have in Blackboard, so from the first one we find out the area for 4.0.95. You can see in the point for 0.95 is 1.64. So that's why we are taking area from here, which is 1.64. So this value for first one, we are taking the value as 1.64, because we see when we have this point z 0.05 on that side, we are calculating this value is 1.64. Be exact, we use 1.645. But if we are using 1.64, that should be pretty good to use for this course. So, but to be exact, this value is 1.645. So this is how we are calculating this. You also can calculate 0.1 using like the same approach. So for finding for finding this value, we have to do, so to find that value, we are doing on that side. We know this area would be 0.1. That means area on that side will be 0.9, right? On that side will be 0.9. So we will go to the Z table and we find the area for 0.9. Then we get the Z value. So let's go to Z value and find the area. Find the point where the area is 0.9, right? And then go to the Z value now and find the area where it's 0.9. So 0.9 is so okay, so this value is pretty close to zero point 0.9, right? This value is pretty close to 0.9, so that's why we're taking 1.2 and 8. So from here, we are taking for this point, taking the value as this one, we are taking the value as 1.28. So then on the same way, we have to calculate the value for 3.125. I hope it would help you. So if you have any question, you can ask me anywhere. So in the class time, I will invite you to join me with WebEx. But always email me, and you also can reach me in my office hour. I will be in WebEx, so I will also send you an invitation, and you will find a link in Blackboard announcement, so that you can always go to the link and you can find me in my WebEx when I have my class hour and when I have my office hour. So please email me if you have any question. We know this is a hard time for you as well, a hard time for us. So I think it will get better day by day. So see you guys.